Welcome my students and viewers to my channel Olympiad Primer. Today in this video I will discuss three different problems on time and distance. The problems are not very difficult, but one point you should learn from this video, you should follow how to learn how to find the solution through logical approach. I have also discussed two ways of solutions: common or general way, that is applying some formulas and solving this, simplifying these formulas. We will also reach the solution, but you will learn how to go through logical approach to find the solution. To find the logical solutions, you have to find out the point of the problem. At first you go through the problem, then before going to the solutions, you may also start from your own effort to solve this, and then you may compare to my solutions with your solutions, and then also you may see the logical approach, how to apply the logical approach to find the solution. To find the logical approach for any problem, at first you will see the sequence of the incidents, and then what you will have to do is you will have to find out the point of incidence where you will see that different distances is covered by two but same time. That means different distances are covered by two entities in same time, and these different distances, the ratio of these different distances will be the ratio of the speed of these two different entities, and that will be the secret equation or a relation of your logical approach, and you will find the solution from this equation very quickly. However difficult the problem, so you will have to find out the two things: either there are two different times taken by same distances by two different entities, then the ratio of these different times will be the ratio of the reverse ratio of their speed. Or you will find a point where you will see that the different distances are covered by two entities or two phases of incidence where the time is taken same. So you will find out either in same time different distances is covered, or in same distances, to cover the same distances, the different times are taken, and these whatever case may be. So where in same time different distances are covered, then the ratio of these different distances will be the ratio of their speed, and when in same distances, to cover the same distances, different times are taken, then the ratio of different times will be the opposite ratio, that means the reverse ratio of their speed. So that is the secret equation of logical approach, and solving this equation only, and this equation will open the secret solution. So okay, let us come to the problems. Let us start for first problem. The first problem is on time and distance. The first problem, arithmetic problem, problem 1. Rina was riding a bike and was 3/8 of the way across a bridge connecting points A and B, and when she heard a train behind her approaching the bridge at 60 miles per hour, she did some quick mental calculations and found that she could just save herself by riding to either end of the bridge, that means to point A or to point B, at her top speed. Then we have to find out Rina's top speed. What is her top speed? This is the question. So well, now we will go for solution, and first we go for common approach to get the solution. Now suppose we draw a figure, and here A B is the bridge 8 miles, and suppose C is the point of the position that Rina, and so AC equal to 3 miles and BC equal to 5 miles, and O is the position of the train when the position of Rina is at C. So clearly, suppose the distance between O and A is D miles, and since 3 miles A to C, we would assume it for convenient assumption, though it is not so realistic, but for convenient assumption we may let this distance between A and C is 3 miles, and then C to B would be 5 miles because AB is the bridge and the length of the bridge is 8 miles, so CB equal to 5. So now for common approach we may write, suppose length of bridge AB equal to 8 miles, if top speed equal to V, suppose the train D miles away from the bridge, so OA equal to D, and then if Rina rides back to A, that is 3 miles, it takes time. We know the time equal to distance divided by velocity, so Rina takes to travel 3 miles equal to 3 by V hour, because we have assumed that Rina's velocity or speed equal to V, and so by so we will get the equation, the time taken by Rina to travel 3 miles equal to 3 by V hour. So the train would take this time to travel D miles, and this time the train would take. So we may write the train would take time 3 by V hour to travel D miles. Then we may get this equation because distance equal to velocity into time. So the train would cover the distance D, and here it would get the time 3 by V hour. So the equation will be d equal to train's speed, that is 60 miles per hour, and into the time taken by it equal to 3 by v hour. So d equal to 60 into 3 by v would be the equation, or vd equal to 180. So this is an equation, we would get it. Now if Rina rides towards B, that is 5 miles, because C to B equal to 5 miles. So if Rina rides this 5 miles, then what will be the time Rina would take? The time t equal to the distance divided by its velocity, Rina's velocity. So the Rina would take the time equal to 5 by v hour, because Rina's velocity is v and distance equal to 5 miles. So 5 by v hour will be the time that Rina would take. But according to question, by this time the train would travel the full distance, that is from O to B, that is d plus 8 miles. So the equation will be d plus 8 equal to 60 into 5 by v, because here the train would take the time same, that is 5 by v, and by its speed, that is 60 miles per hour, and the distance covered by it equal to d plus 8. So the equation will be d plus 8 equal to 60 into 5 by v, or just simplify vd plus 8v equal to 300, and then we would get this equation vd plus 8v equal to 300, and initially we would have the equation vd equal to 180. So putting the value vd equal to 180 in this equation, we get 180 plus 8v equal to 300, or 8v plus 300 8v equal to 300 minus 180. Just simplify, we will get 8v equal to 120, or v equal to 120 by 8, that means 15 and 15 miles per hour. That is that will be the answer, the top speed of Rina. So this is the solution for common approach. Now we go for a logical approach to find the solution of the same problem. Here also we will assume the same. AB is the bridge and C is the position of Rina, and for convenient assumption we will assume that AC equal to 3, BC equal to 5 miles, AC equal to 3 miles, and OA equal to d miles. And now for logical approach, you will have to find out the secret relation, the secret logical relation, whether the same distance is covered by different time, or the same time is taken to travel the different distances. Then the ratio of these different distances would be that in the relation of their speed, the ratio, their speed ratios. So okay, now let us start for logical to find out the logical relation. So logical approach. Suppose length of bridge equal to AB equal to 8 miles, and if Rina rides forward towards B another 3 miles, then we know that according to question the train by this time the train would reach just point A, that is from O to A, that is just at the point A, and then again if Rina rides towards B, that means yet Rina has 2 miles to cross the bridge. The train would reach point A, and then after that if Rina again travels remaining 2 miles, then by the same time the train would travel from A to B just to cross the bridge. So here is the secret relation. That means the time taken by Rina to travel 2 miles, and at the same time the train would travel 8 miles, that means the whole bridge. So clearly this ratio, that means 2 by 8, will be their speed, that means Rina's speed by train speed equal to 2 by 8, and that is 1 by 4. So this is the secret ratios or secret relation of logical approach. So now clearly Rina's top speed will be 1 by 4 into train speed, and we know train speed equal to 60 miles per hour, so 1 by 4 into 60 miles per hour, that means 15. So 15 miles per hour will be the Rina's top speed. So we have got the answer very quickly and in a very short time, and very simple, and this is the logical approach and logical solution of this problem. Next problem on time and distance. Suppose two runners starts a race from two opposite points of a distance A, B. The line AB towards each other. So the first runner starts his run from A, and second runner starts to run from B, and after they meet or cross at a point between A and B, suppose at C, the first man took 1 minute and the second man took 4 minutes to reach their destinations respectively. And then what will be the ratio of their speed? This is the problem. Now we go to solve this question, and now we go for common approach to get the solution. So here we draw a figure, A and B, a line, and the first racer starts from the point A and towards B, and the second racer starts from the point B towards A. And suppose in time t, two racer or two men meet at the point C, and now distance between A and B is supposed to be d, and first man starts from A at speed u, and second one starts from B at speed v. So now if the two racer starts at the same time, and after time t they have met each other. So we know and we write the equation. Two men simultaneously togetherly traveled the distance AB, that means d, and the time taken by them is t, and the velocity, the effective velocity will be u plus v. Then we may write the equation u plus v into t equal to d, because the effective velocity equal to u plus v and the time t. So we may write the equation the distance is equal to velocity into time. So here effective velocity or effective speed equal to u plus v, and that is why u plus v into t equal to d. This is the equation number 1. And again, after meeting or crossing, the first man takes 1 minute to reach A. The second man takes 4 minutes to reach B. So the first man takes total time t plus 1 minute to travel the whole distance AB, that is d. So we may write d equal to u into t plus 1, because u is the speed of the first man and the total distance equal to d, and the time taken by the first man equal to t plus 1. So the equation will be d equal to u into t plus 1. So that is an equation. We have got it. So this equation number is 2. So in a similar way, after crossing each other, the second racer will take 4 minutes, and so the second racer will take a total time of t plus 4 minutes, and if its velocity or speed equal to v, then we may write the equation d equal to v into t plus 4, because distance equal to speed into time. So here the equation d equal to v into t plus 4. So this is the equation number 3. So now we have 3 equations: equation number 1, equation number 2, and equation number 3. So now if we solve these 3 equations, then we may get the ratio u by v. So we may do in this way, putting the value d equal to ut plus vt from the first equation in the second equation, that is d equal to ut plus vt. We may put the value of d in the second equation, then we get ut plus vt equal to ut plus u, or vt equal to u, or t equal to u by v, t equal to u by v. So now dividing equation number 2 by equation number 3, that means if we divide equation number 2 by the equation number 3, then we get d by d equal to u into t plus 1 divided by v into t plus 4, and that is, or d by d equal to 1. So 1 equal to u into u by v plus 1 and v into u by v plus 4. So we have put the value of t equal to u by v, and then we get this equation: 1 equal to u into u by v plus 1 divided by v into u by v plus 4. So here by simplification we get 1 equal to u into u plus v divided by v into u plus 4v, and then cross multiplication 1 equal to only multiplication, only multiplying u in the denominator we get numerator we get u square plus uv, and in the denominator we get multiplying v uv plus 4v square, and then cross multiplication we get uv plus 4v square equal to u square plus 4u, or 4v square equal to u square, or u square by v square equal to 4, and that is u is to v equal to 2 is to 1. So we get u is to v equal to 2 is to 1. So now this is the solution, because we have to find out the ratio of these two racer, these two men, first man and second man, and so u is to v equal to 2 is to 1 will be the solution, and we have the common approach or usual approach. Now for the solution we go for logical approach. What will be the logical approach? The logical approach will be, you have to find out the point where the different distances are traveled by two entities within same time. So is there any point? The assumption are the same. The first man starts from A race, and the second man starts from B. Second man starts run from B, and they at the same time starts running and have crossed each other at the point C, and after crossing the first racer will get 1 minute to reach B, and the second man will take 4 minutes to reach A. So here the first, if you think very clearly, then you will get that at the same time these two men have taken, but their distances, means their traveling distances are different, because the first man or first racer traveled the distance AC, and the second racer or second man traveled the distance BC, but they have taken the same time because they have started the race at the same time, and after some time they have met at the point C. So here AC and BC, these two different distances are traveled by these two men, first man and second man, within the same time. So this is the secret relation, this is the logical point. So clearly this AC and BC will be their direct proportional to their speed, because we know speed and distances are directly proportional. If the time is constant, that means within same time is two particle covers different distances, then their distances are directly proportional to their speed or velocity. So the ratio of their distances, that is AC and BC, AC by BC, or AC is to BC will be their speed. That means U is to V. So now we have to write here for logical approach. After crossing each other at C, the first man took 1 minute and the second man took 4 minutes to reach B and A respectively. That means by the same time taken by both the first man and the second man, the first man travels AC and the second man travels BC. So clearly this AC upon BC will be equal to the first man's speed divided by the second man's speed, and therefore we have written speed of first man divided by speed of second man equal to AC upon BC. So this is the secret relation, and now also or AC by BC equal to U by V, because we have the first man, suppose the first man's speed is U and the second man's speed is V, so U by V, AC by BC equal to U by V. And now you think, after crossing, what happens? Again, first man after crossing C takes 1 minute to travel BC equal to 1 into U, that means U, because we know the distance equal to time into speed. So here BC equal to clearly 1, that means the first man takes 1 minute and its velocity or speed is U. So clearly the first man have crossed, after crossing have traveled the distance BC, so BC equal to 1 into U, that means U. And after crossing, the second man takes 4 minutes to travel AC, so AC equal to 4 into its velocity, that means the second man's velocity we have supposed it to V, so AC equal to 4 into V. So clearly AC equal to 4V. So now here AC by BC will be equal to clearly 4V by U, and this is the second secret relation or equation. So this, if we combine these two equation of AC by BC equal to U by V and AC by BC equal to 4V by U, then we may write AC by BC equal to U by V equal to 4V by U, because we have previously got AC by BC equal to U by V. So U by V equal to 4V by U, and then from this we may write by cross multiplication 4V square equal to U square, and from this we get U square by V square equal to 4, and hence we get U is to V equal to 2 is to 1. So also we get easily the result, the ratio of their speed, that is U to V equal to 2 is to 1. So this is the solution from logical approach. Next, the third problem, and this is very important problem and the last problem, the problem 3 on time and distance. A man returns from his job by train from station A to station B at 4:30 p.m. regularly. Then his private car reaches there at once and takes him on board and goes towards home. He arrives home by his car. This was his normal routine, but one day an exception that he finished his office much early and went by train and reached at station B at 3 p.m. Then he started walking towards home, and when he saw his car coming towards him, he took it and by his own car went towards home and arrived home 30 minutes earlier than normal arrival on normal day. So in this situation, find the ratio of the speeds of car and his walking. This is the question. Now we go for solution, and at first we solve it through normal approach. Then we go for a logical approach. Now let us go for normal solution. Suppose a figure is drawn. The man here from his job place A and by railway track AB, and then from B station he has to return home towards C. C is here home, and the exception day the man from B station towards his home walked up to BD, and from D to C he again returned home by his own car. So suppose AB is equal to railway track and BC equal to road, and C is home, and BD equal to walking distance towards home on that special day. And usual approach will be like this. Normally his car comes to point B to take him at 4:30 p.m. It was given in the question, but that day, that means on that exceptional day, the car comes D and returns at C, and then it will be 30 minutes earlier than normal arrival. So clearly, if the car had traveled to and fro of the road BD, it would have taken this time, that is half an hour, or that means two-way journey of BD equal to 30 minutes. So one-way journey of BD by the car will take the time 15 minutes. So taking 15 minutes for one way from D to B by car. So it implies that meeting time at D equal to 15 minutes normal time, then 4:30. So 4:30 minus 15 minutes equal to 4:15. So actually what happened on that special day is that the man meet the car at the time 4:15 p.m. and it implies that meeting time D equal to 4:15 p.m. So he walks for the period from 3 to 4:15, because it was told in the question that on that special day the man reached the station B at the time 3 p.m. and then he started walking towards D. So the man on that day walked for the time 3 to 4:15, that is 1 hour 15 minutes. So 1 hour is equal to 60, so 60 plus 15 equal to 75 minutes. The man walked for 75 minutes. Then he traveled by his car. So now 1 hour 15 minutes equal to 5 by 4 hour, we may write it. If his speed equal to u, suppose walking speed equal to u, then the distance covered by the walking, that is bd, equal to the speed and the time. So time into speed, 5 by 4 into u. And if speed of the car equal to v, suppose, then the car will take time t, capital T, for one journey of road CB. Suppose the car would take time t for B to C or C to B, that means one way journey of road CB. Suppose the car will take time t. Then we may write the time taken by the car in normal day equal to 2t, go from home to B station, that is C to B, and then B to C for returning. So the car will take time t plus t, that is 2t. But exceptional day, what happened? This time equal to, because the car has to travel only C to D and again return D to C, because the man walked from B to D. So on exceptional day, this time the car that is taken by the car equal to 2 into CD divided by B, that is the distance covered by the car, and that is 2 into, here CD equal to CB minus BD clearly. So 2 into CB minus BD divided by V, that is equal to 2 into, here CB, we write CB equal to V into T, because we know, we have supposed it that the car will take time t and its velocity v. So CB equal to Vt, and then Vt minus here BD equal to BD is the distance covered by the man's walking, and the man's walking speed is supposed to be u. So 5 by 4 into u, we have found out it earlier. So BD equal to 5u by 4. So that is equal to 2 into Vt minus 5u by 4 divided by V. And so this will be the time taken by the car from the two-way journey of C to D and D to C. So now for usual approach, we may now write the equation like this, and this is equal to 2 into Vt minus 5u divided by 4 divided by, that is 2 into Vt by V and minus 5u by 2V, just simplification, and that is equal to 2 into capital T, because V numerator and denominator v is cancelled. 2t minus 5u by 2v. This time will be taken by the car. Since it is half an hour less than normal, so we may write 2t minus this time, that is 2t minus 5v by 2v equal to half, because we know that in normal day the car will take time 2 into t, but on that exceptional day the car has taken the time 2t minus 5v by 2v. So the difference between normal and exceptional is 2t minus 5v by 2v, and that is equal to half an hour according to the problem question. So the equation will be like this, and that is 2t minus 2t plus 5u by 2v equal to half, or v by u equal to 5 by 1, and that is the ratio of the car speed and walking speed. So this is the answer, and this solution is a normal approach, by a normal approach or common solution. But now we go for a logical approach. What will be the logical approach to find out the solution of this problem? Now let us come. Suppose AB equal to railway track and BC equal to road, C is home, all these are the same, and BD equal to walking distance towards home on that day. And the logical approach, if you go for logical approach to find out the solution of this problem, then you have to find out, I have earlier told you that you have to find out the point in the incidence, in the whole incidence you have to imagine, and you have to find out the point where the common distance covered by different time, or the different time or the different distances is covered by same time. Here we can compare the walking speed and the car speed. Now think, that day, that means the special day, the exceptional day, the car returns at C and 30 minutes earlier only because car didn't travel BD twice, that means D to B and B to D, which normally the car has to travel, but on the special day, on the exceptional day, the car didn't travel, hadn't traveled this road, that is D to B and B to D, which one way is covered by walking. That means the man has to walk from B to D that on that special day, and this caused the earlier half an hour. So to travel BD, car would take off half of these 30 minutes, because the car has to take 30 minutes from D to B and B to D. So the car has to take only one way journey of this BD, that is from B to D or D to B. The car will take the time, would take the time half of 30 minutes, that is 15 minutes, and reached the B station. It would reach at 4:30, but on that special day the car has to reach only D and then returns. So 15 minutes from 4:30, that is 4:15, that is 4:15 p.m.
will be the meeting time. So 3 to 4:15, that is 1 hour 15 minutes, that is 75 minutes. The man has taken time from B to D. So here you will see that the same distance BD, if we compare the their speed, then we can think it that the same distance BD, the car has taken the man has taken time 75 minutes, whereas if the car had to travel D to B, it would take time 15 minutes. So the same distance BD, if the car would travel, it would take 15 minutes, whereas the man has taken 75 minutes. So clearly these your secret logical relation will be this different time taken by the car and the man. So clearly we know that their speed generally change, or their speed is indirectly varies of their time, because speed is the distance divided by time. So here clearly we may write car speed by walking speed equal to 75 by 15, because the same distance covered by the car would take the time 15 minutes, whereas the man has taken 75 minutes by walking. So car speed by walking speed equal to walking time by car's time. So 75 divided by 15, that is equal to 5 by 1. So the ratio will be 5:1. The car speed is to walking speed equal to 5:1. That is the answer. So this is the logical approach, and you have learned how to go for logical approach to find out the solution of a problem on time and distance. I think if you get interest, you subscribe and like the channel. So thank you all.